It is the nature of technology that the innovations of tomorrow are built upon the legacy of yesterday. Sometimes we are reminded of this in unexpected ways, such as when in 2024, someone figured out a way to bypass email security by abusing a quirk of the system that only exists for compatibility with mechanical typewriters. Yes, typewriters. Century-and-a-half-old typewriters. My YouTube analytics tell me that most of you have likely never used a typewriter, so here's what you need to know. The bit that holds the paper is called a carriage. Characters are printed by smacking an ink ribbon against a piece of paper with a small hammer in the middle of the device. Each time a character is printed, the carriage shifts to the left to reposition the paper for the next character. When you get to the end of a line and you want to start a new one, two things need to happen. The carriage, which is now way over on the left, needs to slide right and return to its starting position, so the next character is positioned on the left of the page. And the paper needs to feed upwards through the machine so the next character is positioned on the line below. In other words, to start a new line, you need a carriage return and a line feed in order to position the page both horizontally and vertically. If you're wondering what on earth this has to do with computers, there may be some evidence right in front of you. On a lot of keyboards, particularly older ones, the key we usually refer to as Enter doesn't actually say Enter on it, it says Return. That's return as in carriage return. This may not make a lot of sense on a modern system, but early computers needed to consider the needs of the typewriter. Teleprinters were used to deliver messages electronically long before we had email. They were essentially typewriters, but instead of pressing keys directly on the device, you controlled it using electrical signals. This allowed messages to be sent over phone lines, as was the case with telegrams, and it allowed data to be outputted from a computer by having the computer control the teleprinter electronically. These early printers were not like today's printers, they were electronically actuated typewriters. To control it, the computer had to tell it what characters to smash into the ink with hammers, and it also had to tell it when to return the carriage and feed through the next line of paper. To do this, a computer would send a stream of characters, each mapping to a letter on a hammer. For the carriage return and line feed operations, special control characters were used. These control characters didn't trigger a hammer, they triggered a motor. One to move the carriage, one to move the paper. Carriage return, line feed. That's how it worked. The computer would send a stream of characters, and at the end of each line, there would be a carriage return character followed by a line feed character. At some point, of course, this became unnecessary, but once you start down a path in software, it can be difficult to change course without breaking things. The carriage return line feed control character combo was already established as a way for computers to represent a new line in data form. So when Microsoft DOS came along, they didn't want to mess with that. When Windows came along, it was initially based on Microsoft DOS, and they didn't want to break compatibility with DOS either. So even today on Windows 11, if you write a simple text file and press Enter, the computer represents this new line by injecting a carriage return control character and a line feed control character. They're invisible in normal Notepad, but if we use Notepad++ and enable the option to show end-of-line symbols, we can see the special control characters. But let's go back to the teleprinter days. Microsoft DOS might have evolved into today's dominant operating system, but it wasn't the only game in town. Multics was a mainframe operating system with a different sort of problem. It was multi-user. Multiple people could be accessing the printer at the same time. The whole just send your characters to the printer and it'll smack them on an ink ribbon thing doesn't really work when two people are sending characters to it at the same time. The letters would just get muddled together. So Multics opted not to control the printer directly and instead send the data to a piece of software called a device driver and let the driver sort out how to actually operate the printer. Once you've abstracted the data from the mechanical operation of the device like this, you don't need to structure the data based on the printer's mechanical constraints. So why bother with a carriage return and a line feed if you're not actually controlling the carriage or the paper feed and you just need a way to represent a new line? Why not just use one character? Multics chose to drop the carriage return and stick with a single line feed character. Fast forward to today, Unix was inspired by Multics, Linux was inspired by Unix, and a modern Linux system also uses a single line feed character. Apple also chose to use a single character, but they chose carriage return instead of line feed. At least they did until OS X, when they rebuilt their operating system around a BSD-based Unix kernel, and inherited line feed as a new line character from that point forwards. The result of all of this is that because of how different operating systems evolved with the need to control physical teleprinter hardware under different conditions, and because everything we have today inherits from everything that came before, different operating systems today represent new lines in text using slightly different methods that all kind of relate to mechanical operations and typewriters. Most people would never know or care. Most documents you use are not plain text files and have more complex formatting anyway. It can be an issue if you do any programming. If I write a bash script on my Windows PC and copy it to a Linux server, I have to convert the line endings or Linux will get confused by the unexpected carriage returns. Largely speaking though, it's not a big issue. Linux does Linux, Windows does Windows, Mac does, well, it depends how old your Mac is. But there is a scenario where this line ending inconsistency needs to be sorted out. What if you're defining a cross-platform text-based communication protocol? If every operating system needs to communicate with every other using text, they need to be on the same page. No pun intended. This is exactly the case with SMTP, the protocol used to send and receive emails. You have no idea what operating system an email server might be using. It has no idea what operating system every client or every other server it might need to talk to is going to be using. You can't have one party spitting out carriage returns when the other is expecting a line feed, so what do? Well, the answer is quite straightforward really. You have a standard. SMTP standard is carriage return line feed. It doesn't matter what your operating system's native line ending is, when you talk to an email server, you treat it like a typewriter. To give you an insight into this, I'll show you what an email conversation actually looks like. Most of the time these days you'll be using an application to do it, so you don't actually see the raw conversation. It's all text. Everything gets converted into text. Even images get encoded as text. First, we'll introduce ourselves by saying hello and the name of our server. This isn't a typo, it was changed to hello instead of hello in later versions. It means it understands the newer protocol extensions. Next, we tell the server who our email is from, then who our recipient is. Finally, we send the data that makes up the actual email. When we're done, we put a single dot on an otherwise empty line. The important part is that each of these commands must be terminated with carriage return line feed, and the end of the email data is marked by a dot on an otherwise empty line. In other words, carriage return line feed, dot, carriage return line feed. That's a standard everyone needs to follow, but not everybody did. Let's say a developer from the Unix world doesn't bother to read the standard properly and incorrectly sends line feed characters as line terminators without carriage returns. Is it really necessary to penalise such a person by rejecting their emails, when really it isn't exactly rocket science to interpret what they're intending to do? Well, the short answer is yes, but implementations have varied. Some email servers allow it, some don't, some allow it by default and you can turn that behaviour off, some disallow it by default and you can turn that behaviour on. It depends what email server you're using, what specific version of the software it's running, and how it's configured. Notably, the SendMail software that was really popular back in the Unix heyday wasn't originally too fussy, and the now popular Exim and Postfix servers allowed it because SendMail did. They want to be drop-in replacements for SendMail, and you can't be a drop-in replacement if your software rejects emails that the thing you're replacing would have accepted. But how did it leave us with a security bypass in 2024, nearly a century and a half after the first typewriter? Individually, this actually works fine, but isolated email servers that don't talk to each other would be pointless, and it's common for organizations to have multiple servers running different software. Microsoft Exchange, for example, is really popular for hosting business mailboxes, because it's a full collaboration platform that integrates email, calendaring, resource scheduling, data synchronization, contacts, telephony, file sharing, instant messaging, mobile device management, and plenty of other services. All of those features make it a bit of a beast though, so if you just need to move emails around, it's massive bloated overkill. Postfix and Exim, on the other hand, just move emails around, and they're much more efficient at doing so because they don't need to care if your phone is in sync or if it has a PIN code enforced, because that's just not their problem. Because different software is better at different things, it is very common to see them used in combination. You might have emails coming into an anti-spam system that uses Exim, then delivered to a mailbox server that runs Exchange, and it might forward some of them to an application that ingests them using Postfix. Or you might use Exchange Online in the cloud, and it might forward some messages to an archival system that uses Exim, while an on-premises Postfix server relays messages from local services to Exchange. It's all very normal, and it's all very dangerous if they're not following the same standard. Let's consider a scenario with two servers running different software. What you have to appreciate about email is that it's a massive target for abuse. When I showed you that raw conversation, you might have wondered, what's stopping me from typing any address as the from address? And the answer is absolutely nothing. I can put anything I want in there. In technological terms, email is ancient, and they just weren't thinking about security when they put it together. All of that had to be retrofitted. Let's say this server follows the SMTP standard to the letter, and it's an internet-facing one. The other is internal, and it's a bit more blasé about line endings. It is the internet-facing server's job to validate the senders of messages coming in from the internet. I have a whole video on technologies you can use to do this that I'll link in the description. But the basic version is that other organizations publish the locations of their servers on the internet. When your server receives a message claiming to be from another organization, it looks up these records and compares them to see if the server sending the message is on the list. That's what this server will be doing. This one is much simpler. It doesn't receive messages from the internet, so it will just have an explicit list of trusted sources. It'll trust the first server that has done the internet security filtering for it, it'll trust this scanner over here that scans documents and emails them, and it'll trust this business application that sends notifications to your staff when something important happens. Anything else? If you're not on the list of explicitly trusted devices, it won't even talk to you. This is a fairly typical setup. The goal is that an innocent email like this one will be allowed through. But if I were to try and spoof the sender and pretend to be your boss and ask you to pay an invoice for me, the internet-facing server is going to check the sender and go, "Hold on a minute, this email address is one of mine and I don't recognize this server. You're not on any list I see, go away." But what if we delete this carriage return? We send both emails one after the other, but we stuff up one line ending so it doesn't match the standard. What will happen? Server number 1 follows the standard. Carriage return line feed and these commands, all good. Data section, all good. A dot followed by a carriage return line feed. Well, this would be the end of the email, except this dot isn't on an empty line. There's a missing carriage return here, so this is not a new line. This means this dot is just part of the preceding line, and instead of being the end of the email, it's literally just a dot character in the email. This next line, well, it's just part of the email as well. And the next. In fact, all of this is just part of the first email, and when we get all the way down here, we have a correctly terminated end of email message. So even though it looks kind of like two messages, if we parse this according to the SMTP standard, it is a single message sent from an external party, and if you look up the allowed senders for this email address, the sending server is on the list. It's legitimate, even if to a human the content looks a bit odd. I mean, it's probably not even that odd. I've sent messages like this, it looks like a message trace an administrator might get. But here's where it all goes wrong. The second server. How will it interpret the same message now it's been forwarded on? SMTP commands look good. Data section looks good. Oh, that's like the end of a message, but they've used the wrong line ending. Whatever, I'll allow it, send that message. Okay, new message here, SMTP commands look good, data section looks good, end of message. What should I do with it? Well, did it come from a trusted server? Yes, it came from this server, and I know I can trust this server, so send away. Dave, pay the invoice. Or maybe it's not even directed at one of your people. Maybe the recipient is external. Normally, an external party would not be allowed to relay messages through your server back out to the internet. But it isn't external, is it? It's coming from an internal sender going to an external recipient, and it's from a trusted internal server, so it's all good. Now, when that gets sent, it's even trickier to detect, because from the target recipient's perspective, it's an email claiming to be from your organization, and it legitimately came from your organization's server. It's going to get straight through, they're going to pay the invoice, and when they realize they've been scammed, they're going to come after you, because you actually did send them that email. They paid it because it came from your server. If you're using DKIM, it will be signed with your digital signature too. They can prove all of this and they will make it your problem. Typewriters. As crazy as it sounds, this is all because of typewriters, the way computers evolved to control them as teleprinters, and the legacy of that which still runs through the devices we use today. What can you do about the vulnerability today? Well, patches are being released to make the likes of Postfix follow the standard properly. If all servers agree to treat email like a typewriter and send a carriage return line feed, the problem goes away. Keep an eye out for patches. I'll drop some links to information about the vulnerability in the video description. Let me know if you've been impacted by this, and hit the like button if you've learned something new. It's down there next to the subscribe and share buttons. They do get lonely if you don't use them.